Welcome back everybody to part 2 of our Unity Retro 2D Platformer tutorial series. In the last episode we created our scene and we've added our character Waluigi into our scene, but we have no means of interacting or even playing our game yet, and that is what we're going to focus on in this episode. Before we do, I'd like us to tidy up our hierarchy a little bit by creating, via right click, a new empty game object. Don't forget to reset its position to 0, 0, 0, and let's name this level. Anything we create, any game objects we create relative to our level, we will make children of our new level parent game object, just like that. There we go. Now that we've done that, go ahead and minimize our level parent game object, and let's go to our character. Highlight our character, and we can rename him now. So let's rename him Player. There we go. Now let me take you over to the inspector. As I said, the inspector displays all the information about our game object. We have two components as of now. We have a transform, that's our position in our scene, and scale and rotation. We have a sprite renderer, which renders the sprite that we select. As you can see, we have our idle sprite right there. And if you look below, we have add component. Go ahead and select add component, and you should see a list of components we can add to our player game object. We want to move our player game object using physics. In order to do that, we need to add a physics component called a rigid body. In the search bar here, let's find rigid body. There we go. We have rigid body and rigid body 2D. As we're working in 2D, it's important to stick to convention. So let's select rigid body 2D, and there we go. We have a rigid body 2D component on our player game object. He can now experience things such as gravity. We have a gravity scale here, default set to 1. So let's go ahead and press play and have a look at that in action, shall we? So when our game finally loads, there we go, sway! He's falling into oblivion. He will not stop. Why? Because no collisions are being made between any of our game objects, in our example the player, and the ground. In order for collisions to happen, we need to add another component known as a collider. So go ahead and add component. In the search bar, let's find, nice and simple, a box collider 2D. There we are, that fits our sprite perfectly. And we're also going to need to add a box collider 2D to our ground, our walls and our ceiling also. So let's go ahead and do that. Let's go to our level game object, open it up, select ground and add component, box collider 2D. There we go. But you'll see that our collider is only small. It fits the size of just one of our blocks. We need to change that size so the collider snugly fits our game object. So let's change the size along the x-axis equal to the number of units in size that is. Now 1 unit is the size of one of our blocks. So in the inspector, in the box collider 2D component, change the size on the x-axis equal to the number of blocks your ground is. In this case, I have 23. I'll expand it by 23 units in size, and there we go. It fits the ground perfectly. Now, if we go ahead and press play, our player should no longer fall through into oblivion. He should land nice and comfortably. There we go, that was good. It's important to note that in order for two game objects to collide and for the collisions to happen, one of those game objects needs to have a rigid body as well as a collider component. In our example, it's our player. Every other game object that we want our player to collide with will only need a collider component, because our player is going to be our main means of interacting with this game. Right, so that's our player and our ground sorted for colliders. Let's apply the same to our ceiling and our two walls. For the ceiling, it's going to mirror exactly what we did for ground. So let's add component, box collider 2D, change the size along the x-axis by 23, and there we go. Left wall, add component, box collider 2D, and oh, something's not right. Unlike when we added our box collider to our ground, which was snug around our center block, this one is offset. That's because, and if some of you may have noticed in the first video, I did not reset the parent game object of our left wall. I did not reset the position. This is an example as to why you should always make sure that your position is reset. But there's a fix for this. Unfortunately, we do have to remake this component, because even resetting it does not fix the problem, because it affects all the children as well, all the child game objects. So go ahead and delete, go back to basics, our block, reset the position for our block. Let's rebuild this wall real quick. Control D. There we are. Because whatever changes in position you make to the parent game object will also affect the children as well. And as you can see, the child game objects will also grossly offset. There we are. We've fixed our wall. Let's go ahead and add our box collider. There we go. It's now in the center, and this time we want to change the size on the y-axis by however many number of blocks we have. In my case, I have 9. There we go. And let's reposition that back over there. And we don't have to do the same for the right wall, because we're going to replace it. Highlight the right wall, right click, delete, and let's duplicate the left wall, bring that over. There we go. Rename that to right wall, and there we go. Problem solved. Alrighty, now we have all our collisions in place for all our game objects in our scene. Let's go ahead and bring our player character to life. We're going to write our first lines of code to help this guy move and jump. The language we're going to use is C#, and we're going to go to our scripts folder, right click inside, go create, and create C# script. We have to name our script, so let's name it player controller. All functions that are going to control our player, going to take effect on our player, we're going to put in here. Once that's compiled, double click, and it should open up Visual Studio. Once Visual Studio has opened up, you should be met with a screen that looks like this. If you haven't got Visual Studio, do not worry, it should have come as part of your Unity installation. If not, there'll be a link in the description down below on where you can download it. Let's take a look at the information we already have in our player controller script. We have void start and void update. These are what are called functions. Functions are tiny little packages where we can write our code that will be called into effect when something happens. For example, void start is called before the first frame of the update. In other words, it's called on frame 1 and only frame 1. When something enters our scene, what's in void start will immediately happen, and only once. Void update, on the other hand, is very different, as it is called every frame and is the most commonly used function that is used for almost any game behaviors, but not for physics. For physics, which we want to use, we're going to create a new function. So let's click into our script, go down to the bottom here, just below void update, And let's type in the keyword void. This basically means that the function won't return any values to anything else outside from within its own function. It keeps it contained. And we're going to call this one, by default, fixed update. End it there with open and close brackets, with open and close curly brackets beneath. Now this is where physics calculations are going to happen. And a fixed update is better suited for this than update, because fixed update is called every fixed frame rate. For example, when adding a velocity, which we're going to do to our rigid body 2D, that velocity is going to be applied every fixed frame inside of our fixed update, instead of every frame inside of update, as it better calculates the physics simulations per frame taking place for a smoother execution, because fixed frames don't run as often. If we were to write our physics calculations, our code, in void update, because they're getting called every frame, we run the risk of them overlapping each other, and that can cause all manner of bugs further down the line and can be quite resource heavy on our game. A function is nothing, however, without its variables. Variables are the building blocks of our code. It's the information that we can store to be used by our functions. This information could be things like player stats, such as health, speed, ammo, whatever you like for your game. So let's go ahead and write our first variable. Let's click at the top here. It's important that any variables and functions we write are kept between these two curly brackets here. Press return, create a space or two, and we're going to type in public float speed. Let me break this down for you. We need a speed variable that is going to be our velocity, how fast we want our character to move. Float is a number, specifically a decimal number, so our speed can be anywhere from 0.1 to 100.2, and public basically means that this speed variable is accessible to other scripts. It's public information. We also want the same for our jump. So let's go ahead and write public float, and we'll call this one jump force. This will control and determine how high and how hard our character can jump. Once you've done that, Control S to save our code, and let's go into Unity. Let the code compile for a little bit, and when it's ready, we can drag our player controller script onto our player game object, whether in the hierarchy or in the inspector. There we go. We've now added our player controller script as a component to our game object. And you can see here are the two variables that we have named, speed and jump force. You can see that they have had the first character capitalized in the inspector, and they're currently both at 0. We can access this information in the inspector because it's public, and we can change our values on the fly as we're testing. Let's go back into our script and let's write another public variable called a bool. Public bool, and we'll call it can move. Now a bool is essentially like a switch that can have two outcomes, either true or false, on and off. What's going to determine whether our bool can move is true or false is going to be our input, our directional input to move our character. We also need to reference our rigid body 2D component on our game object in our script as well in order to use it. So let's type in private. This means we just need to reference it and read it within player controller script. Rigid body 2D, don't forget about that naming convention, and simply call this the rigid body 2D. There we go. And we need to reference this in our start function. So go ahead, type in the name of our rigid body 2D, which is the RB2D. There you go, it's automatically saved. And equals. So how do we call and get this component? We type in get component, open some pointy brackets, and type in rigid body 2D, and close it with two brackets like that, and end with a semicolon. It's important we end our code with semicolons. Save that, and let's just go back into Unity and check that our code is compiling correctly. It may take a little while to load, and there we go. We can already see that we have our new public variable, our bool can move. We can press that little box, on, off, true, false, true, false. We can't see our rigid body variable that we wrote because it's private. Anything that's private will not show in the inspector. It's only exclusive to that script. Anything that's public, as I said before, is public information, and we can also access it and make changes on the fly in our inspector. So we don't really need our bool can move to be public, so let's go back and change it to private. So just change public to private, save, and you should see when we go back in, it's compiling in the corner there, that can move will disappear. There we go. It's now a private variable. Now that we have our first few variables in place, let's have a look at how we're going to move our character. If you go to the top here, edit, drop to project settings, click input, open up this option here, axis, and you can see we have horizontal and vertical. These are our two axes in the game. Horizontal is our x-axis, vertical is our y-axis. Now there are keys already bound to these. If you open up horizontal, you can see the name has already been set as horizontal, and we have the left, right, A and D keys already bound to this axis. If you go to vertical, you'll see the same. We have up, down, S, W, they're bound to our vertical axis. When we press either of these buttons, they're going to return a value. The value will be either positive or negative. If you go back into our scene, highlight our player, and let's get our move tool. There we go, so we can see some arrows. If we press, say, the right arrow key, that's going to return a value of 1 along the x-axis. If we were to press our up arrow key, that will return a value of 1 on the y-axis. And if we press our left key or our down key, that's going to return a value of -1 on the x or y-axis respectively. So let's go and start typing this out in code. So what do we want to do? We want to say that when a button input has been made, something happens. And we do this in our update function here, using what's called an if statement. So go ahead and write if, open up the brackets, input dot get axis raw, open up another set of brackets, and we're going to name the axis we want to use. And when we write a name, we always use quotation marks, and that name is horizontal. Make sure the spelling is correct. So if the input of that button returns a value that is going to be greater than 0.5 f, f means that number represents a float, or we can type or using two vertical bars, our input dot get axis raw, and we're going to write that same line of code again. So open up your brackets, quotations, and our name horizontal, and outside here we're going to write if that value is less than -0.5 f, and at the end of the brackets here press return and open up two curly brackets. So to break down what we've just written, this input here is going to represent our right directional buttons, as they're going to return a value of +1. So our value will be greater than 0.5. These inputs here are going to be our left directional button inputs, and we know, as we saw before, that they're going to return a value of -1, so their value is going to be less than minus 0.5. So this is our left directional movement, and these are our right directional movement buttons. So when we press any of those and hold them down, can move is going to be equal to true, and we end that with a semicolon. So when we press left or right directional buttons, can move becomes true every frame that our buttons are pressed or held down. Now this is all well and good, but at the minute nothing is being called when can move equals true. At the bottom here, we're going to write our function called move player, end with the open close brackets, and what we're going to say is if can move, so if can move is equal to true, then this happens. What's going to happen is we're going to apply a velocity to our rigid body that's going to move our player. So let's type the RB2D dot velocity equals a new vector 2. Now a vector 2 represents the coordinates of our player within our scene. If we go back to Unity, go to the top here where we have our transform, we can see our current position on X and Y are 0 and 0. If we move our player, we can see that our X value increases by a positive number. If we move to the left, it's by a negative number. Go back into our script and let's dictate what values we're going to influence. So open up some brackets. This will be our X coordinate as we are going to move along the X axis, and we're going to multiply our input dot get axis, same again as we wrote before, horizontal. We're going to multiply that value, we use asterisks to multiply, by our speed. So when we press our right directional button, that's going to be a value of 1 times our speed. If we press to go left, that's going to be -1 times our speed, so it will move us in each respective direction. For our Y value, we're just going to say the rigid body dot velocity dot Y, as our Y value is going to change throughout the entire scene as we move. End with a semicolon. Now at the minute we've input all our code to move our character, but nothing will happen in Unity as we need to call this function in our fixed update. So let's type in the name of our function, move player. It's important when we're referencing and calling functions, we end it with open and closed brackets. Save that now. Let's go into Unity, wait for our code to compile, and when it does, let's go to the bottom to our player controller script. Let's give our speed variable a value of 5, and let's press play. When our game loads and our player hits the ground, if we press any of our left and right inputs now, we can see that our player moves. And if we scroll in the inspector while keeping the game on play, we can see our values along our vector coordinates is now changing to a minus value or a positive value, left or right. And while we're at it, let's see our speed increase. Let's change the value to 10. Click on our game view, and there we go. We can see he's moving much faster. So let's exit that now, and let's go back into our code, where in the next episode, we are going to write more code to make our character jump. Thank you very much, guys. I much appreciate your company, and I will see you soon.